Assalamu alaikum warahmatullahi wabarakatuh. Good morning, students. Um, Today we are going to start lecture 11. Okay, so here see the materials what you have. So far you have studied in the last lecture from the ER diagram how you convert it into a conceptual model. Now in this lecture 11, we are going to study about normalization part 1. Okay, normalization part 1. Now let us see what is this one. So in this lecture, the first objective covered is what is normalization and what is the role that it will have on the database designing process. You have designed the database, but how well you have designed the database, that we can come to know after this topic. Then the second objective that you will cover in this lecture is data redundancy. What it is, what is the meaning of data redundancy, how it happens. And the third objective that we will cover in this lecture is an anomaly. Anomaly means the differences, the variations. So there are different types of variations in the data. That means inconsistency. The data will not be consistent. Suppose you have data in three different servers. So the data what you have in the first server will be different from the data existing in the second server, which is the copy of the first server. So that topic we will cover in the types of anomalies. Fourth objective is normalization process. What is the steps that you have to follow in order to do the normalization of your database tables? Okay. Then fifth objective is we will study some basic things in order to understand the normalization types. That is called functional dependency, partial dependency, and transitive dependency. These are the types. Then you will come to know the last but one objective. How many types of normal forms are there? What are there? Then how to convert the first normal form, second normal form to third normal. Up to this one only we will cover in this lecture 11. Now let us start with the first topic called what is normalization. Why we do this one? See, this is the process, this is the steps that you are using for evaluating your database tables and correcting the database table structures by minimizing the data redundancy, means data inconsistency. You are going to organize your tables structure properly. You are going to correct your table structure properly so that you can minimize the data redundancy. So that is what called your normalization. So normalization, what it will do, it will help you to remove or minimize. It will help you to reduce the inconsistency. Anomalies means inconsistencies among the data, differences among the data. See, irregularity, differences, abnormality, inconsistencies. This is the meaning for the word anomaly. Then when you do the normalization, we have to convert your database tables structures into this format: one NF, that is first normal form; second normal form 2NF; third normal form 3NF. So up to this one we will study in the lecture 11. So I have prepared the tutorial for this one, so I would like to take you to that one so that you can easily understand. So as I gave you now the definition, normalization is nothing but the technique, the method of organizing the data in multiple related tables, the tables which are related. Why we are doing like this? To minimize the redundancy. Or you can use this definition just now I give. Evaluating and correcting the structures of the table to minimize the redundancy. Okay. Now next topic for you is need. Why we need this one? Why normalization is required? So this is used when you are going to do the designing of your new database. You are going to start a new system design. That time we go for this normalization. So normalization will do the analysis of relationships among the attributes within each entity. So what is the relationship among one column name with the other column name? That you are going to do the analysis. By doing this analysis, we can make sure whether the table structure can be improved by studying, by analyzing the columns in your database table, that is called entity. So if you do this one, then you can improve the structure of the table, and also your database design will be good database design. Now we are telling here redundancy. This redundancy we are telling. What is this redundancy? Next is that question. What is data redundancy? Why we have to reduce it? It is nothing but repetition of the data increases the size of the database. Already I told you redundancy means the multiple copies of the data. Repeated data is there in your table. Example, see this is the table. If you have four records, rows or tuples in your database, then you can see the last attribute, maybe like city, it is having the data, same data. Su. The city name is repeated. Imagine if you have million records in your table. So million times you are repeating the same words, same data in the column city. That will increase the size of the database. It will occupy a huge size. We are talking about just one attribute. There can be many attributes in your database project. So if this happens, if this repeatancy happens, it will bring you some problems. What are the problems? These are the problems. At the time of inserting the data, you will face a problem. At the time of deleting the data, you will face a problem. At the time of updating the data, you will face a problem. So if you don't remove or if you don't minimize this repeated data, problem number one, two, three, and other problems may be faced. Now let us see what is this first problem. You are getting this, students? What I am trying to explain you, are you getting? Students, are you getting what I am explaining to you? Students, are you focusing on what I am explaining? Are you there, or all of you are putting on mute and doing your work? Maybe you are not awake. You may think that recording is there, why we should attend the lecture. Students, are you following what I am explaining? Voice, that means you are not awake. Maybe you don't want to talk. Sleeping, maybe. Sleeping time. The first problem, see here, redundancy. I am trying to explain what is redundancy. Another example is this one. Suppose you have this one, this table, students table. So in the students table, you have the columns, your registration number, name, what is your major, who is your head of the department, and the telephone number of the head of the department. Now see this one, student name Ahmed is studying computer science and engineering, CSE major. And the HOD name is Mr. X and number is this one. So if you have some four records, your table structure will look like this. What if you have some million students in your students table? This part of the data is unnecessarily repeated many times. When the new student joins, that time also you are trying to put the same data here. So this is what called redundancy, this red color cluster I am showing to you. This we have to remove or minimize. Okay? So this data repetition will lead to the problem of redundancy and the size of the database is increasing. So final, what is the result will have is slowness in the application performance. So you are accessing SIS portal. So SIS portal, if you access, you will say, Mr. The internet is very slow. The website is very slow. Why? This could be the reason. If you have not designed your database properly, you have to face such type of slowness in the data. Such type of slowness in the data. Traffic of the data increases. Other issues will arise due to the increase in the size of the database. Okay, these are the problems. Some problems, as I told you, insertion anomaly, deletion anomaly, and updation anomaly. Understand, students? So what is the first one? Insertion anomaly. So if we have to enter the new student data in the example, what you have, this one. So fifth student, if I want to insert number 5, like Osama. So he is also from computer science engineering. Then the HOD is same. Then the phone number is same. So why I need to always repeat this data? So imagine if you are adding 100 new students to the table, then what will be the situation of the data? 100 times you have to enter the same data. Name of the HOD, which major you are, and what is your office number. So same data, repeated data, if you are inserting, it will bring the problem called insertion anomaly. Insertion anomaly. That is the first problem. Now we will look for the second problem, deletion anomaly. In this table, if you observe, we are storing two pieces of information. This one, if you closely watch, if you closely understand this table, what type of data we are storing here? One, we are storing about the student information we are storing in the student table. Also, we are storing about the branch information. That means your college information, branch, which branch you want, which campus you want. You are from Sur, or you are from Salala, or from Nizwa, or Ibri, or Sohar, etc. So that is the observation here. So we are storing two pieces of information in the above table. Okay. Now, if you start deleting the data, if you start deleting the student information from this table, okay, I will delete this one, the row will be deleted. I will delete this one, the row will be deleted, the row will be deleted, the row will be deleted. Last row, if I delete, then I will delete the student information as well as the branch information. So if I delete all records, finally you will not have any data here. You will unwantedly lose the information of a student as well as the student is studying in which branch. Why we need to delete the branch information? We can delete only student, no? But here in this table, they are in the same table. There's all attributes, roll number, name, major, HOD, office. So if you start deleting, it will delete the complete data, which will lead to the loss of related information. So this information student is related with the branch. So unknowingly, you are going to delete both information when you try to delete the student information. So this is what happening, the problem called deletion anomaly. Understanding, students? Good.
Yes, Mister.
So this is a second problem. Problem number three is while updating the data, that time you will face this problem called updation anomaly. Now imagine that the head of the department is leaving the college and new head of the department, Mr. Y, is joining the college in your IT department. Then in your tables, student table, you have to update the name of the HOD from Mr. X to Mr. Y. But see here, you have to do the same task for all the records. Understand the situation of the database administrator who will do this job of updating. If you have millions and millions of records, then you have to update all of them. If any one of that record is not updated, that will lead you to many problems, inconsistency problems. So the administrator has to update all the records present in the table. If you have many records, then you have to update all those things. And if you don't update it properly, that will lead to the updation inconsistency, updation abnormality. Okay, so for this reason we have to minimize the repeated data. So we have to go for normalization. So normalization will solve the above discussed problems. What are they? Insertion anomaly, updation anomaly, and deletion anomaly. What we will do simply is we will divide your table into two different parts. See here we have this one. First one is student table. Now you put the student information in the student table and the remaining columns branch information in the branch table. Then you have a relationship between them. See that structure will look you like this. So this is your student table. Now you have only roll number, that is your registration number, name of the student, what is the major of the student. Then in the branch table, you have here like major, head of the department, and office. This is your this thing, okay? Major. I want to correct it. Major. So, okay. So now we have the branch information here and the major information here. Sorry, the student information here. So we organize the data into two different tables. This is the first table and this is the second table. So this will solve the problem of this insertion, updation, deletion. So the data is stored here. See, instead of repeating the data CSC, Mr. Y, and phone number for all the records, one time only you are going to put it here. What is the ID? That is the major ID here. So CSE, Computer Science Engineering. So if you want to know the details of what is CSE, then you can refer in this branch table or department table. So this is the branch name, this is the HOD name, this is the telephone number name. So this is called your normalization process. Understand, student, here what is this normalization? Students, understand this one? What is this normalization? Students, hello? Are you understanding or not?
Yes, Mr. Understand.
I will show you one video here up to what I explained. Do you understand that one? Easy process for you. With voice, I will listen, make you listen.
We'll try to understand the concept of normalization in database. We will start with understanding what all problems arise if a table or a database is not normalized and how normalization solves these problems. So what is normalization? Normalization is a technique of organizing the data into multiple related tables to minimize data redundancy. Now you would ask, what is data redundancy and why should we reduce it? Well, data redundancy is nothing but repetition of similar data at multiple places. And we want to reduce it not just because repetition of similar data multiple times eats up extra space, but it also leads to multiple other issues like insertion, deletion, and updation anomalies. For now, let's start with a very basic example and try to understand data redundancy and the problems that we face due to it. So here we have a simple student table which stores student information in a college. We have columns: roll number, student name, the branch or the department name, the name of the HOD or the head of the department, you can call it a teacher name as well, and the department telephone.
Why should you invest in stocks on eToro?
With eToro, I can invest in US stocks with phone number. Now let's put data of 4 computer science students into this table. We'll add roll number 1, 2, 3, and 4. Put in the student's name, their branch name, the name of the HOD, and the department telephone number. Now in this case, the branch name, the HOD name, and the telephone number are same for all the entries that we make. Whenever a new student entry is created, this entire information is repeated, and this is what is redundancy. Now this data redundancy not only increases the size of our DB unnecessarily, but it also leads to multiple other issues like we talked about. So let's see what these issues are. There are 3 main problems that data redundancy causes. These are the insertion anomaly, the deletion anomaly, and the updation anomaly. So let's start with insertion anomaly. Now we already have 4 students data in our table. If we have to add a 5th student, we will have to repeat the same data which holds the branch information like branch name, the name of the HOD, and the branch telephone number again. And if we have to enter the data for 100 more students, we have to repeat the data 100 more times, which leads to insertion anomaly, because the repetition of data will only increase as we insert more entries to our table. Now this repetition arises because in our example, we are unknowingly, unintentionally saving 2 pieces of information in every row: student information and branch information. Now if we start deleting student information, the branch information is also deleted simultaneously. And when we delete the last student row from the student table, we also unintentionally delete the branch information. So now we don't have any student information, and we also don't have the branch information because we deleted it, which leads to deletion problems and is also known as deletion anomaly. Now let's see what updation anomaly or modification anomaly is. So let's say if the HOD or the head of the department leaves for some reason, making the students happy, and the department gets a new HOD, and the system administrator has to update all the student records with the new name of the HOD. This is modification anomaly because this is hell lot of a work which the administrator has to do to update every single record with the new HOD name. And during modification, if even a single row is missed out, it will lead to inconsistent data. Hence, data redundancy can also lead to inconsistency in data as a result of updation anomaly. Now you understand that data redundancy is pure evil, not only because it eats up extra space, but it leads to problem in inserting new data, deleting the data, and a huge problem if we have to update the data.
Good grammar and spelling are important.
So now the million-dollar question is how normalization will solve this problem. So normalization will break the existing student table into two different tables, student table and branch table. The student table will save the data of the student and the branch table will save the branch information. Now the branch information, if we want to save data of computer science department students, will be just one row. That will be the branch name, computer science, the name of the HOD, the new HOD I must say because the old HOD left, and the phone number of the department. And in the student table, we'll keep all the information of the students enrolled for this particular branch. And these tables will be related by the name of the branch in our case, which is CSE. One can say that the branch name is still getting repeated in the students table. So normalization is not about eliminating data redundancy. It's about minimizing data redundancy. So now, earlier where all the branch information was getting repeated with each and every student record, now only the branch name is repeated because the branch information is kept in a different table. And if we want to update any branch information, we just have to update it at one place. And it will automatically be updated when we fetch a student record because the student record is connected with the branch record using the branch name. And if we update the HOD name or the phone number in the branch table, it's updated for all the students. Now, as redundancy is minimized, hence the problems which arise due to it are also minimized. Let's see how the problems are solved. Now, if we have to insert a new student data, we only have to enter the roll number, the student name, and just the branch name because the branch information is stored separately and we don't have to modify or insert it again. When we have to delete student information at the end of a session to store information of the students for the new batch, we can just delete all the student records and we'll still have the branch information, branch details in a separate table, save. And if we have to update the name of the HOD again or the department's phone number, we just have to do it in one place. See how normalization solves a lot of problems by just dividing the data into separate independent logical entities and relating them using a common key or you can say a unique name. In our case, that is the branch name.
Understand now, students? So what we have done now, we have done normalization in order to solve the problems what we discussed: insertion anomaly, deletion anomaly, and updation anomaly. Now we are going to understand what is required in order to do the normalization. So you have to learn some certain definitions, which is given here, which is called functional dependency. So whatever we covered in our lecture is up to up up to. See here they have explained to you. They gave you this example. They gave you this table, and they are telling you about the updation anomaly, the deletion anomaly, and the insertion anomaly. And now we will move to the normalization process. What is it and what is this dependency? So we will start this one. Okay, so you should not store the same unnecessarily data in the same table. You can keep it in the different table. Now let us study what is required for you now. See, functional dependency. Example 1 I am giving you here. So if I say that A is a column and B is a column, and if I write like this, A arrow B, arrow means here it is determining B. A determines B. We will read it as like this: A determines B. That means this B, column B is depending on column A. So here B is called determinant. Okay, similarly here imagine there are three columns like A, B, C. They are deriving column D. That means D is fully dependent or functionally dependent on A, B, C attributes. In another words, if I say like student ID determines student name. Student name is depending on student ID. That is the meaning here. So if you don't know student ID, we cannot determine the value of this column, student name. So this is what called functional dependency. Another example I gave you here is like you have a student ID, student name, it may be your pata ka shakhsiya rakam and your result. So here I am saying that this ID is a primary key and as well as the civil ID. So with these two, we can identify the each instance of the entity row. So if you are combining this column and this column, then it is called a composite primary key, student ID and civil ID. So now in order to determine, see grade column is there, your result. Your result is depending on these two keys, primary keys. So without knowing your ID and your civil number, I cannot find out your grade. So they are functionally dependent on this one, civil ID, and the grade is fully dependent on both these columns, functional dependency and fully functional dependency we are learning here. So the same is explained to you here in your slides. What is the determinant? What is the dependent? That I explained to you just now. So fully functional means the entire collection of attributes is determinant. In the determinant is necessary for the relationship. Examples given here, see. Project number determines project name. That means project name is functionally dependent. Project name is depending on project number, or you can also read as project number functionally determines project name. So this one is the determinant attribute, project number. So I told you here what determinant. And the project name is known as dependent attribute. So this one is your dependent attribute. So V is known as dependent. I think you are depending on A. B is depending on A. So A is the determinant. Functional dependence, that's one. Okay. fully functional dependent means it's a suppose the attribute B is functionally dependent on a composite key. So B is called fully dependent on A, the example which I gave you here. So imagine that this is your attribute grade. Grade is fully depending on ID as well as the student ID as well as the civil ID. Next, partial dependency. What is this partial dependency? So in the below data, what I am going to show you here, like student data. And this is the table name. Student ID you have, project ID you have, student name you have, and the name of the project you have. So in order to find the student name, you must know the student ID. That means this column is depending on student ID. In order to know the project name, you must know the project ID number. So this column is depending on this column. So these are the determinants, this one and this one, and these are dependent attributes. Okay, so now both student name and project name are non-prime attributes. That means they are not primary key. They are depending on these two columns. This is what called a partial dependency. I am going to show you that one here. See, student name can be determined by the student ID, which is the partial relation, as well as project name can be determined by the project number as a partial dependent. So this dependency you have to remove. How you will remove? You will put the project information in separate table and you will put the student information in separate table. That's it, simple. So here it is explained to you in another example like this. Imagine these two columns is deriving these two columns. A, B determines C, D, and column B determines C. That meaning A, B is the primary key here. So C is depending on only a part of the primary key. So primary key for us is A and B, but C is depending on only B. B is also a part of the primary key. So you are going to determine the value of C with the help of this one. So in the same example here, I gave you these two are primary keys. Student ID and project number. This one, two, both of them are primary keys. So if you want to know the project name is depending on this one. It is not depending on the student ID. So that is why it is called partial dependent. Understanding, students?
Yes, Master.
Next definition, what you need to understand is transitive dependency. See, example is given like this. Your attribute is functionally depends on another non-key attribute. X depends on X deriving Y. Y derives Z. That means here X is the primary key. So in this case, X also determines Z. That is a transitive relationship, transitive dependency. So The x determines the value of z through y. Example I will give you here. Transitive dependency. Now see here, A determines B, B determines C. Then C is transitively depending on A through B. Imagine you have a table like this, movie listing. You have the table column, movie ID, list ID, listing type, and the price of the DVD. So here the listing type means this movie is what category? Is it crime, adventure, drama, action, or the sci-fi movie? Which type of movie is this? That one. Okay, now see here example. Movie ID determines the list ID and list ID determines listing type. That means movie ID determines listing type. This is the transitive dependency you have here. You can see here. Movie ID determines list ID and list ID determines list type. So that means this can be determined with the help of list ID, but that is given in the relationship like this here. Movie ID determines listing type. This is known as your transitive dependency, same as we have discussed here. So C is transitively depending on A. So this list type is depending on movie ID. So you are going to find the value of this one through list ID. So these three, why we are discussing functional dependency, partial dependency, and transitive dependency, because we are going to use these things now. Now I will move to the types of normalization. So you have normal forms, this one. Next slide number 16. So this is called first normal form. When do you say that the table structure is in first normal form? You have proper format, there is no repeated group of attributes, and the primary key is there. Then it is called first normal form. Then we will move to second normal form, third normal form, BCNF and 4NF. These are all the normal forms. So in this lecture, we cover up to third normal form. Remaining two we will cover in the lecture 12. Now let us see what is the first normal form and what is the process in order to convert your table into first normal form. That we will understand now. So here I have given to you rules, some rules. So first normal form rules. So each column of the table must contain atomic values. See here you have a column 1, column 2. So for A, you have two values, X and Y. This is wrong. You should not have multiple values in one cell. Second rule, column must contain values of the same data type. See here there is a column for the table here called date of birth, and here is a column name. So in the date of birth column, you have to store the same data type, date of birth only. Don't store the other values here like name of the table. Do not intermix, do not interchange the values into the columns. So in the place of name, don't put the date. In the place of date, don't put the name. This is avoiding, you have to avoid this rule. Next rule, all the columns should have unique name. If you have same name, it will be difficult to get the data. So all the columns, see here, suppose if this is a table, like in your name you have first name, last name, etc. So if you have like that, don't give the same name. You should give the different column names like this. First name, last name, tribe name, family name, like that. And number 4 rule, the order of the data which you saved is not important. That means the records can be in any order, like first 3, then 4, then 1, then 2, like this. Order is not important. So if you have like this, then you can say that your data is in normal form, first normal form. Okay. Now let us go to here first normal form example. Now let us see this table, students table. Suppose you have student ID, name and subject. So student 101 name is A, studying operating system and computer networks. Student 103 is studying Java subject. Student 102 is studying C programming and C++ programming. So by seeing this data, you can identify that whatever we discuss the rules, from the 4 rules, 3 rules are satisfied. Only one rule is not satisfied. What is that rule? This rule. It's atomic values. You have multiple values here. Where is that? This one. For this record, you have 2 values, operating system and computer networks. For this record, you have 2 values, C and C++. So what you have to do is you have to break this. This is the violation of 1NF, first normal form. So you have to divide this one, break the multiple values and keep them as another row like this. 101 is studying OS, again repeat 101 is studying computer networks. 102 is studying C programming, another is 102 studying C++ programming. This is somewhat we have minimized the redundancy. This is in the normal form. So the same one I will show you in the video here. First normal form.
We studied about the basic concept of normalization. We saw and understood how data redundancy can lead to several issues and how normalization can reduce data redundancy and make the data more meaningful. In this video, we will learn about the first normal form, which is like the step 1 of the normalization process. The first normal form expects you to design your table in such a way that it can easily be extended and it is easier for you to retrieve data from it whenever required. If a table or a database is not even in first normal form, it is considered as bad database design. So we can say first normal form is the basic requirement, and to follow this should become your default nature while creating tables to store data. Also, it is the step 1 to move on to second and third normal form. The first normal form expects you to follow a few simple rules while designing your database, and they are: rule number 1, each column of your table must be single valued, which means it should not contain multiple values. We will explain this with help of an example later. Let's see the other rules for now. Rule number 2, this is more of a common sense rule. In each column, the value stored must be of the same kind. For example, if you name a column date of birth to save date of births of a set of people, then you cannot or you must not save names of some of them in that column along with date of births of others in that particular column. It should hold only date of birth for all the entries or rows. Rule number 3 expects each column to have a unique name. This is to avoid confusion at the time of retrieving data. If one or more columns have the same name, the DBMS system will be left confused. Rule number 4 says that the order in which you store the data in your table doesn't matter. Although all the rules are self-explanatory, still, let's take an example where we will create a table to store student data, which will have student's roll number, their name, and the name of subjects they have opted for. So we will be creating a table with 3 columns. We can obviously have as many columns in our table as we want, but for our example, we only need 3. We will name the columns roll number, name, subject. Let's add some data to our table. Now with data added, our table already satisfies 3 rules out of the 4 rules. As all our column names are unique, we have stored data in the order we want it to, and we have not mixed different types of data in our columns. But out of the 3 different students in our table, 2 have opted for more than one subject, and we have stored the subject names in a single column. But as per first normal form, each column should contain atomic values. Now, how to solve this problem? It's very simple because all we have to do is break the values into atomic values. By doing so, although few values are getting repeated, but values in the subject column is now atomic for each row, hence a table is in first normal form.
So this is what the first normal form, what we achieved. We have minimized the redundancy. Okay, so this is the rules you have to follow in order to go to our normal form. So where is your image normal form? So you have raw data. From the raw data, you are converting into first normal form. When do you say your data or the table structure is in first normal form? When there is no repeated group of data and primary key is identified. Then we call it as the first normal form. So further, the table structure can be improved by applying or by moving to the second normal form. So for the first normal form, you improve again second normal form. Second normal form is nothing but eliminating the partial dependency present in the table. So as I have discussed before, what is partial dependency here? This is partial dependency. So you have the primary key, student ID, project number. So project name is depending only on this one. It is not depending on the student ID. This is the partial dependency. So that we have to remove now in the second normal form. So then your table will be in the second normal form if you delete that partial dependency. So what is the rule for the data or your table to be in the second normal form? First of all, the table structure should be in the first normal form. That is the first requirement. The second requirement is it should not have any partial dependencies. So imagine here in this table, student table, you have the student information and the branch information. Now you are going to store the data, divide the table like this. Student information, you put it in student table. The score information you put in the, that means marks information you put in the marks table, and the subject information you put in the subject table. So this will bring your data to be in second normal form. So for that, again, I will like to play the video of second normal form.
I need to.
So second normal form, the
We will
one.
cover the second normal form of normalization. We will discuss about the criteria required for a table to be in second normal form and why second normal form is so important. For a table to be in second normal form, it must satisfy two conditions. First one, the table should be in the first normal form, and the second one, there should be no partial dependency in the table. We have already covered the first normal form in a previous video, so if you missed that video, we suggest you to go check out that video first. Now the main question is, what is partial dependency? To understand partial dependency, we first need to understand what dependency in a table is. So let's take an example of a student table in which we save student's name, student's registration number, student's branch, and student's address, etc. In this table, student ID is the primary key and is unique for every row. Hence, we can use the student ID to fetch any row from this table, even for a case where student names are same. If we know the student ID, we can easily fetch the correct row or column of data. Primary key is nothing but a column or at times a group of columns which can uniquely identify each row in the table, or in simple words, all you need is the primary key to fetch any data from the table. For example, I can say give me the branch name of student with ID 10 and I can get it. Similarly, if I ask for name of student ID 10, I will get it. So all I need is student ID and every other column depends on it. This is dependency in table. Now that we know what dependency is, we are in a better state to understand what partial dependency is. So for a simple table like student, a single column, which is student ID, can uniquely identify the complete row or all the other columns in a row. But this is not true all the time. Now let's extend our example to see if more than one column together can act as a primary key or not. Let's create another table for subject. In this table, we have subject ID, which is the primary key for this table, and the subject name. Again, subject ID can be used to get all the information stored in all the other columns. Unfortunately, there is only one other column in this case. Now we have a student table with student information and another table for subjects. During exams, another table score is created to store the marks obtained by every student in the respective subjects. Also, name of the teacher who teaches the subject is saved along with the marks. So in our score table, we will have columns score ID, student ID, subject ID, marks, and teacher name. Let's add some data to this table. As you can see in the score table, we are saving student ID to know which student's marks are these, subject ID to know for which subject the marks are, and the marks and the teacher name. In this table, we can say that the primary key is score ID, but student ID and subject ID together forms a more meaningful primary key for this table.
Here is a composite key here, student ID plus subject ID.
And we can fetch all the information using it. You would ask how? See, if I ask you to get me marks of student with student ID 10, can you get it from this table? No, because you don't know for which subject. And if I give you a subject ID, you don't know for which student. Hence, we need student ID and subject ID together to uniquely identify any row of data, because we have a many-to-many relationship here. When I say that we have a many-to-many relationship here, I mean a student can appear for any number of subjects test. Also, a subject can be opted by any number of students. Now, if you look at the score table, we have a column named teacher, which is only dependent on the subject. For Java, it is Java teacher. For C++, it is C++ teacher, and so on. Now, as we just discussed, our primary key here is a composition of two columns, which is student ID and subject ID. But the teacher's name only depends on subject. It has nothing to do with student ID. This is partial dependency. And for a table to be in second normal form, this should not exist. Now the question arises how to remove this. There can be many different solutions for this, but our objective is to remove teacher's name from score table. We can do this in many different possible ways. One of the ways is to move teacher name to the subject table where it fits appropriately along with the subject names. We can also add the respective teacher's name. Or we can also create another table for teacher and use the teacher's ID wherever we want. So this is the second normal form.
So this is a simple way. What is our objective is to remove the uh, partial dependency. So partial dependency is this one. So this column is depending on this one. It does not depend on student ID. So keep the data of the teacher in the teacher table or into some other table. So in this way, we can eliminate the partial dependency. So that is our objective here. No partial dependencies.
But the teacher's name only depends on to remove teacher's name from score table. We can also create another table for teacher and use the teacher's ID wherever we want. So this is the second normal.
So this is about the second normal form. That means your data is getting purified now. First it was in raw format. Now it is in first normal form. Then again now we are in the second normal form. So the second normal form, the table must be in the first normal form and there should not be any partial dependency. Now the last one is third normal form in this lecture 11. When you will say that your table is in third normal form, first of all, the requirement is the table must be in the second normal form. Also, there should not be any transitive dependencies in your table structure. So that is our third normal form. So third normal form is you are going to eliminate the transitive dependencies. So requirements are this one. So now example is this one. You have student table, you have subject table, you have score table, and you have exams table. So if you have the tables like these, then we can say our data is in the third normal form. So let us see the small example of this one.
Win it, golden! Normal form. If you're following a normalization videos from starting, then you must have already seen the videos for the first and the second normal forms. If not, I suggest you to watch those videos before starting with this one. In the last video, we learned about the second normal form and even normalized our score table into the second normal form. For a quick recap, we had three tables: student, subject, and score. Following were the primary keys. Score table had teacher's name, which was only dependent on subject, so we moved it to the subject table. Hence, now the score table is normalized to the second normal form. But we missed to add some information in the score table in our last video. We need to save exam name and total marks also in the score table. So should we just add them in the score table? Let's do it. So here is our updated score table. So coming back to the third normal form, for a table or a relationship to be in third normal form, it must be in the second normal form and it should not have transitive dependency. Remember partial dependency? This time it's transitive dependency. They're different. To understand what partial dependency is once and for all, watch our video for the second normal form. So what is transitive dependency? With exam name and total marks fields, our score table now looks like this. Primary key for our score table is a composite key, which means it's made up of two attributes or columns, student ID plus subject ID. As we can see, our new column exam name depends on student and subject. For example, a mechanical engineering student will have workshop exam, but a computer science student won't. And for some subjects, you have practical exams, and for some, you don't. So we can say that exam name depends on student and subject both. And a second new column, total marks. Does it depend on student or subject or marks or the new column exam name? Well, total marks depends on exam name. You must be thinking how. In our colleges, practical exams are generally of 40 marks or 30 marks, and theory exams are for 70 or 60.
This is our case only. See, lab exam, you have marks like 32 internal marks, means the semester marks is 40 marks, and the final exam marks is like 60 marks, or 30 marks for the internal and 70 marks for the external. The same is the concept here.
Marks. Sessionals are of around 40-50 marks. So all in all, total marks changes based on exam. Hence, we can say that total marks depends upon the exam name.
So based on the subject, like introduction to database, the total mark is different. Based on your data structure subject exam name, the total marks is different.
Now in our table, we already know that the primary key is student ID plus subject ID. And all other columns or attributes depends on it, except total marks, which depends on exam name. But exam name is not a part of a primary key, right? This is transitive dependency. When there is an attribute in a table which depends on some non-prime attribute and not on the prime attributes. And the solution to this problem is take exam name and total marks and put them in an exam table and use exam ID wherever required. So now our score table is storing more information and it is in the third normal form.
So this is the simple way of dividing your table and storing it into the different groups. So this way we will solve the problem of the redundancy and we can eliminate many anomalies. So that is what we have covered here. In your slides, it is given as this example. This is the table they gave you, and this is in the first normal form they are telling you. So how you converted this table to the first normal form is they have shown you these steps. See, in the exam, you have to draw this type of diagram. So this diagram is called dependency diagram. So dependency diagram will show the dependencies within the table structure. So it will tell you what are the relationships among the attributes. Okay, this is the important one. They will give you the table, and with that table you have to draw this diagram. Okay, this is called dependency diagram. So I have given you in the tutorial this link. You can go to this link and refer how to draw this dependency diagram. This one. So imagine this is your table, like student table. You have in that columns, this is like a bus like this. Student ID, student name, campus address, major, course ID, course title, who is the instructor, and what is the location of the instructor, and what is your result. So this data, what are the primary keys, what are the foreign keys, how they are related, that you have to show with the help of these arrows. See, this arrow determines that here, see, student ID and course ID are the primary keys. They need to determine your grade. Another relationship here is student ID determines student name, campus address, and major. Similarly, course ID determines course title, instructor name, instructor location. So like this you have to draw. If they give you like this box, this lengthy box, these arrow marks you have to draw. So these all when you combine, that is this diagram. This is called dependency diagram. So this I have drawn in first step, second step, third step. These three diagrams is this one, dependency diagram. So in your slides, it has been given some other example called this project example. This one. See, project number determines project name. Okay. So project name will determine this one, employee name, employee class, what is the charging hour, that means the salary, and for how many hours you work. So this is the first normal form. In the first normal form, these two are the primary keys and these are the derived attributes. And what is the partial dependency in this one, that you have to write like this? What is the transitive dependency, that you have to write like this? Sometimes they will give you this picture without these names, labels, and you have to write like this: first normal form, what is a second normal form, what is a third normal form, and what are the dependencies. So this one is in the first normal form. The second normal form is you have to remove the partial dependency. This one, partial dependency, you have to remove. See, the charging hour is depending on the type of job. So if you are a teacher, how much you are charging your salary. If you are an engineer, how much you are charging your salary. But this one is not depending on the project number. So it is depending on your primary key, this one employee number. So that we have to remove here. That means you store it in separate table. So this is your first table, project, which will have only project information. The second table will have employee information. Similarly, you remove the transitive dependency. See, this charging hour is depending on job class, but job class is not a primary key. So that's why this details the assignment of the job. You create a new table called assignment. In that, you store the assigning hours. Assignment table. So assignment, what are the attributes? Project number, employee number, assigning hours. So this is your this is your second normal form. Now the third normal form is like this. Assigning hours, you are going to put it in separate one. Job hours, you are going to put it in separate. So 4 tables. Before you have only one table like this. From this you are going to divide it until you reach this third normal. That means the transitive dependency is eliminated. Same I have given you in student example like this. So first normal form is this one. So second normal form, I am going to remove the partial dependency here. So keep the student information in the student table and the course ID and the result table in the registration table. See, the grade is depending on the this one, course ID, as well as on student ID. But this is partially depending on this one because dependent before. Now you have removed that dependency. Okay, but still you have here the in the course table you have instructor name. Instructor name determines where is the instructor. He is in Sur, he is in Misbah, he is in Sohar, he is in Salala, he is in Ibri, or he is in Rustaq, he is in some other place. So this is depending on this, but this is not a primary key. That is what called transitive dependency. So that you will put it in another table, instructor table. So you have student table, you have registration table, you have course table, you have instructor table. Now you are showing the relationship. This is the foreign key here in the registration and that is a primary key here. So course ID is a foreign key that is having a relationship in the course table, which is a primary key. So instructor name is a primary key here, that is a foreign key here in the course. So like this, you have to show. So I will just, you can watch, I will give you this one. You can watch this one in order to draw that dependency diagram.
PRPs look at the relationships between entities. Normalization looks at the relationships between attributes. In other words, the dependencies. Let's go through a simple example. This table is already in first normal form because, as can be seen, each cell has a single value and each repeating group attribute contains a data value. To go from first normal form to higher level normal forms, you need to draw a dependency diagram. The dependency diagram will allow you to see all the dependencies among the attributes from far. To draw the dependency diagram, we line all the attributes horizontally as if they are a bus windows. To show the dependencies, we then draw arrows leading from the determinant to the dependent attribute. Looking at the table again, while student ID is not unique, it's clear that for each instance of student ID, the values for student name are the same. The values for campus address are the same, and the values for major are also the same. Course ID is unique, but alone it cannot determine the grade of a student. A grade is dependent on course ID and student ID, and this is a composite primary key. Since there is a composite key, i.e. the primary key is made up of two keys, you may have to create up to 3 new entities. But course ID can alone determine course title, instructor name, and instructor location. Since an instructor can only be in one physical location, instructor name determines instructor location, and this is a transitive dependency. Now to move to second normal form, I will draw a relation for each primary key and the attribute it alone determines, or on its own, or by itself. So I will draw a relation for student ID, student name, campus address, and major, and call this relation student. I will also draw a relation for course ID, course title, instructor name, and instructor location, because course ID can alone determine these attributes. I will call this relation course. Next, I will draw a relation for the primary keys combined, i.e. the composite key. So my registration relation will have ID.
Yeah. Yeah.
I have another lecture.
Over finish time. Okay. So please, this is the end of our lecture 11. So I will put this video as well as this one. So please refer to that. We will continue in the next class. Okay. This is just finished this one. Just you have a half minute that one. So they are showing you how to convert it into the third normal form. That's okay. If you want, you can leave. I will take the attendance. All of you are having class now?
Yes, Ustad.
Okay, we'll continue tomorrow. Okay.
Okay, see.
Okay, thank you. Okay, you can move. I will take the attendance later from this Google Meet. Then we can see that. Okay, I'll stop the recording.